Okay, we'll do this chapter similarity from the beginning. So last year you had this chapter called congruency. And when you say two shapes are congruent, what does it mean? It means they are same in shape and size. Okay, they look exactly the same. Their shape is the same and their size is also the same. In similarity, shape is same, but not the size. Size can be different. So here if you see these two shapes, they both are squares. And so they are similar in shape, but their size is different. So these two squares are said to be similar. Look at these two equilateral triangles. Equilateral triangles, they will always be same in shape, but their size can be different. Okay, one small and one big. So two squares will always be similar and two equilateral triangles will always be similar. Like there is no way of making two squares that are not similar. Because if you make two squares, their shape is always same. Right? Similarly, if you make two equilateral triangles, their shape is always the same. You can't make two equilateral triangles that have a different shape. Can you tell me any other shape which will always be similar to each other? A circle, small circle, big circle. The shape is always similar, only size is different. So circles are always similar. Any other shape that is always similar? Are two rectangles always similar? See, one rectangle can be like this. Another rectangle can be like this. See, they're rectangles. But are their shapes same? No, one rectangle is longer than the other rectangle, right? So rectangles are not always similar to each other. But these shapes, that is a square, an equilateral triangle, not just any triangle, equilateral triangle and a circle are always similar in shape. The symbol for similar is like this, just a tilde. Okay. For congruency, last year you had this tilde with equal to sign. That means they're exactly same. It's called a tilde. This okay, it's on the keyboard. This button is there under the escape. Okay, so only tilde means that is similar. Tilde with the equal to sign means what? Congruent. Okay, so this is not congruent. Okay, any other shape? This is not congruent. A line, not a line. Yeah, a line segment. Two line segments are always similar because their shape is same, but size can be different. Okay. All right. So in this chapter, you're learning only about similar triangles, not equilateral triangles, because equilateral triangles are always similar, but you're proving that two triangles are similar. Okay. Now here you have two triangles. Do they look similar? Yes. So what is same for these two triangles? Huh? Shape, obviously. But a triangle has two parts. There are sides and there are angles. So for these two triangles, what is equal? Are the angles equal or are the sides equal or what? The angles are all equal to each other. So angle A will be equal to angle P. Angle B is equal to angle Q. And angle C is equal to angle R. So all the three angles are equal. Okay. First is one angle. Angle A is equal to angle P. Second angle B is equal to angle Q. And angle C, clear, is equal to what? Angle R. So three parts we have which are equal. And then you have three more parts. Which are the three more parts are? The sides. Okay. Now are the sides equal? AB is not equal to PQ, but it is proportional. Proportionally, see, obviously the left side triangle is bigger than the right side triangle. So when you're converting the AB into PQ, it's proportionally becoming smaller. Like all the three sides are proportionally getting smaller to each other. So how do you show the three sides are equal to each other is not equal, proportional to each other is you take the corresponding sides. Corresponding means matching sides. Which is the side corresponding to AB? PQ. So you have to write like this. AB upon PQ will be equal to the next set of corresponding sides. So say BC. BC is corresponding to which side? Huh? QR. Okay. And the third set of corresponding sides are AC and AC and PR. Okay, so like this, you'll have a relationship between the three of the sides. They are proportional to each other. These set of corresponding sides will be proportional to the next set of corresponding sides, which will be proportional to the next set of corresponding sides. Is that clear, Leah? All right. So 6 parts. Out of the 6 parts, 3 angles are equal and the 3 sides are proportional. Okay, now let's give an example. Let's put some numbers over here. Say this is 6, 8, 4. 3, 4, 2. Look at the sides. Okay, let's apply these values in this formula. How much is AB? 6 upon PQ?
3.
3. Is it equal to the next set of corresponding sides? BC is 4 upon QR is 2 and AC 8 and 4. Are these equal to each other? Yes, if you cut them,
Yes.
you'll get 2. Here also 2. Here also 2. You see, all the sides, all the corresponding sides are proportional to each other. Say that statement, everyone. Corresponding sides
Corresponding side.
are
Proportional to each
proportional
other.
to each other. Which is the side corresponding to AB?
PQ.
PQ. So those are the corresponding sides. So one set of corresponding side, there are 3 sets of corresponding sides, right? And those 3 sets of corresponding sides are proportional to each other. Okay, that's the property for similar triangles. Is everyone clear? How do you show that triangles are similar? All these 6 parts should be satisfied. 3 angles should be equal and the 3 sides should be proportional. So totally how many parts are there? There are 6 parts. Okay, but we don't have to show all 6 parts are equal or proportional. You just have to show 3. So you have some properties here. Okay, the first property is, do you know these properties? Let's go in the order at which it is in your book. Okay, the first property is angle-angle property. Let me just go through all of them first. Okay. All right. Let's see. Yeah, here are the 3. The first one is SAS. That is side angle side. So if you have side angle side, say this is a triangle. So one side should be proportional to the side over here. I mean, this 2 set of corresponding sides should be proportional to the next 2 set of corresponding sides. And the angle in between them should be equal. This angle should be equal. This is SAS. You always need to have at least 2 sides because you need to compare one set of sides with the other set of sides. So this is SAS. Okay. So if you have first triangle as ABC and the second triangle as XYZ, now tell me, which are the sides that are proportional? How do you write them? AB upon
XY.
XY will be equal to BC upon YZ.
Y.
Okay, and the angle, which angle will be equal?
Angle B is equal to angle Y.
Angle B will be equal to angle Y. Okay, so if you're able to prove this much, just 3 parts, 2 sides and 1 angle, then automatically all 6 parts will be equal or proportional to each other. Okay. All right. Write down this much. Show this much first. Come on, write quickly. First, you're showing that for similar triangles, all these properties should be true. And then we're seeing the first property or condition for similarity. There's another name also. Properties, conditions are also called postulates. Okay, the word you'll see postulates used more in the book. See SAS postulate. Okay, is everyone done with this?
Yes.
Right, so we'll see the second postulate or condition. In the second postulate is called AA. That means angle, angle. Why not angle, angle, angle? Because if two angles are equal, automatically the third angle will be equal. Right? In a triangle, when you add the three angles, you will get 180. So if two angles are equal, then third angle has to be equal. Then only when you add everything, you will get 180. Okay? Explain. All right. So let's see these two triangles. So if this angle and this angle, say this angle A and angle B, here angle X, angle Y. Yeah, when you mark it, also use this uh, like this type of marking, okay? Double angle or single angle. Okay, so this shows you that angle A is equal to angle X and angle B is equal to angle Y. Okay, so automatically what happens? The third angle will be equal to the other, which you don't have to prove. So if you just prove this much, then the two triangles are equal. Okay, a simple one, draw this. We'll go to the next. The third one is SSS. That means all the three sides should be proportional to each other. You don't have to show any angle. You show all the three sides are proportional to each other and they will be equal. So how will it be? AB upon XY will be equal to BC upon YZ, which will be equal to AC upon, correct? Exit. Okay, this is SSS. Write this down. Okay, look at the next question here. I mean, look at the first question here, question number 1, and look at it and tell me what to do. Now, for this, you'll have to remember all the properties of lines and angles that you have learned in 7th standard. Okay, so let me just quickly go through those properties of lines and angles, then only you can do this. Okay, if you have two parallel lines, then you have a line cutting this, then this line is called a transversal. Remember that? Okay, so now you have some properties. This and this angle here. What do we call them?
Angle bisector.
No. All right, so this middle section over here is the interior region, and top and down is called the exterior. Okay, so any angle that's drawn in this part over here is the interior. So these two angles are interior, right? If I draw an angle over here, see this and this and this and this, that becomes exterior. Okay, so both the angles that we have are interior angles, right? Okay, so and they are one on left on one on the right. They're alternate to each other. So they're called what? Alternate interior angles. Okay, that's the first property. Alternate interior angles. So what do you know about alternate interior angles? They will be equal to each other. You see, this is an obtuse angle. This is also an obtuse angle. It's greater than 90. So they will be equal. Yeah, that's the first property. Next property, this and this. What do you call this? Huh? Now, are they interior? Yes, both are interior and both are on the same side. So they are called co-interior. Remember this? Now, co-interior angles, do they look equal? Are they equal? No, one is big, one is small. So what property do you have for them?
Angle.
They are supplementary. It means if you add them, you will get 180 degrees. So if you have one angle, let's say this is 70, say this is 70 over here, then this will be how much? 110 degrees. Understand? Draw these two. Okay. Next one. Come on, you should know this now. This and this. What do we call these angles? Corresponding angles. What's the property for corresponding angles? See, there are only two properties. Either they're equal or they're supplementary. So what are these two? They're equal to each other. You can see now both are small, less than 90. If they both, see, I just see open mouth and closed mouth. Okay, both are closed mouth means they're equal to each other. Both are open mouth means they're equal to each other. If one is open, one is closed, it means they're supplementary. That's all you have to remember. Okay, so corresponding angles are equal to each other. These are the three properties. You can modify these three properties and come up with more properties. But if you just know these three, then that's all. Okay, draw this. Okay, now I'll draw two angles. You tell me what property. Okay.
Supplement.
I didn't get you. Speak louder, please. That's half of it. They're not interior. See, they're outside, no? So they're alternate exterior angles. Clear? Because the exterior, no? Remember, interior was this part here. All right, so alternate exterior. Okay, next, this and this. Corresponding angles. These two.
Co-interior.
Co-interior. These two. Co-exterior. Co-exterior. See, both are exterior and on the same side. So co-exterior. These two. Alternate interior angles. Now tell me what's the property also. Are they equal or are they supplementary?
Equal.
These two are equal. Okay, these two.
Supplement.
Yeah, tell the property. I mean, tell the name and the property. So, co-interior, supplementary. Corresponding and equal. This class is for everyone, okay? Only not only Yvonne and Beryl, even Leah also. Leah, tell me next now. Next three you have to tell me. What is this?
Corresponding.
Equal.
Equal.
Next.
Corresponding equal.
Next.
Exterior. Alternate exterior. Equal.
Alternate exterior angles. Property?
Equal.
They're equal. Alternate angles are always equal. This?
Supplementary equal.
No. This is not any property. Because one is interior, one is exterior, and they're alternate. So there's no property like this, okay? You have to come up with some property. For example, maybe find this, these two. These two are what?
Co-interior.
They're co-interior. So if suppose this is 100 degrees, then this will be 80 degree. And then you can find this. How much is this?
80 degrees.
What is the property between these two? There's another name for that now.
Alternate angles are equal.
Vertically opposite. You see these two, they are called. So let's call that the fourth property. Vertically, actually, these come before, because for this you don't need parallel lines. You just need two intersecting lines, and you have these properties. Okay, so you have vertically opposite angles. Vertically opposite angles will always be equal, and then you also have this. What are these two? Linear pair. Linear pair is supplementary. Okay, so write down these two properties also, fourth and fifth, vertically opposite and linear pair.
But in linear pair, both the side 90 degrees will be there.
Not
What?
90-90. They should add up to 180. If one is 100, the other can be 80. If one is 110, the other has to be 70. Okay, it can be like this. So for this triangle, we have this angle over here, which I'm pointing at, that's APC, is vertically opposite to angle DPB. So that's your first side or first part that's equal. These two angles are vertically opposite, so they're equal to each other. Next, we have angle A is equal to angle B. If you see AC and BD, they are parallel to each other. So if two lines are parallel, then this line here AB is a transversal, cutting both the parallel lines. So angle A is on one side of the transversal, angle B is on the other side of the transversal. So they are alternate interior angles. They are equal, angle A and angle B. Third angle that's equal is angle C and angle D. Why? Same reason. AC is parallel to BD, and here the transversal is CD. So this angle C is on one side of the transversal, angle D is on the other side of the transversal. So they're again alternate interior angles. So since we have used all three angles, we have shown that all three angles are equal to each other. So therefore, by the AAA postulate, triangle APC is similar to triangle BPD. This much you write, you'll get your full marks. Is that clear? All right, write this down. Okay, next. Now, once you have proven that the two triangles are similar to each other, what does it mean? It means all six parts are proportional to each other. That means all the three sides are proportional and all the three angles are equal to each other. What did I say? Once we have shown that the two triangles are similar, that means what? All six parts. Six parts means what? Three angles, three sides. They're all proportional to each other. Proportional means the angles are equal and the sides are proportional. Is that clear? Okay. So now we have to write the statement. Corresponding sides of congruent triangles are proportional. What is that? Corresponding sides or corresponding parts. Parts means all angles and sides. Corresponding parts, that means matching parts of similar triangles. Two triangles are similar, right? So corresponding part of similar triangles are proportional. Last year we used to write this thing CPCT. You remember that? CPCT means corresponding parts of congruent triangle. But they're not congruent triangle. These are similar triangles, right? So we have write corresponding parts of similar triangles are proportional to each other. That means all the three sides and all the three angles are proportional. So now look at the next question. The next question is to do with the sides. They have given some sides. Okay, we'll mark them down. They have given some sides and they have asked you to find some other sides. Okay, so let's put these values on the diagram here. BD is 2.4. BD is 2.4 centimeters. AC 3.6. PD 4. PD is 4. And PB is 3.2. PB is 3.2. Find the length of PA and PC. Okay, so it's to do with all the sides. Okay, now since we wrote the statement, corresponding parts of similar triangles are proportional, therefore, all the sides are proportional to each other. Which are the sides proportional to each other?
AP upon DB.
AP and
Upon DB.
Which is the other side that's corresponding to AP?
PB.
PB. Remember, AP and PB are what?
Vertical opposite angles.
They're not angles, they're sides. What do we call these two sides, AP and PB? We call them corresponding sides. Corresponding means matching sides. Okay. So this set of corresponding side will be proportional to the next set of corresponding sides. Which is the next set of corresponding sides? Say AC. AC, which
AC upon DB.
BD. Right. AC and BD are the matching sides. So they are the corresponding sides. And which is the third set of corresponding sides?
CP upon
CP and
PD.
DP. Or right. CP and DP are dash sides. What sides? Corresponding sides. So all these three sets of corresponding sides are dash to each other. Proportional to each other. You should know these words, how to use them, okay? Corresponding sides are proportional to each other. Corresponding means matching. Proportional means if you divide them, you will get equal values. Okay? All right. Now, since we have this, let us use them to find the missing value. Okay. So first, let's find AP. Okay, so AP is where? AP is here. We don't have AP. We don't have CP. CP. I'm just highlighting the missing values. Remaining values we have. Correct? All right. So if we want to find AP, we can use these two ratios and cross multiply. If you want to find CP, you can use these two, cross multiply and find the missing value. Is everyone clear how to do this? All right, write this down and solve it and tell me the answer. Okay, how much is AP?
4.8.
4.8.
AP is 4.8. Okay, and CP?
4.8.
6.
6. Okay, do you understand how to do it? Does anyone have any doubt? So you will write the statement. When you only take these two ratios, you will write there taking required ratios. Because you're not taking all three, right? You're only taking two. Which one you require? So you have to write there taking required ratios. So then you're taking only the required. That is AP upon PB is equal to AC upon BD. Right? And there you're substituting the values and finding the missing the ratio. Okay, so just remember to write that statement. Just write it down. Taking required ratios. Okay, let's go to the next question here. See question number 7. In the given figure, DE is parallel to BC. AE is given, EC is given, NC is given, BN, where is B? BN is given. Write all possible pairs of similar triangles. Okay, so tell me, by looking itself, tell me which all triangles do you think are similar to each other?
ABN is similar to ANC.
No. What, once again? Beryl, AB is similar to ADM. Yes, ABN, that's this big triangle, is similar to the small triangle here, ADM. How do we prove that? Corresponding angles, which is corresponding. I'll just draw it here. See this angle and this angle. They're corresponding. So they're equal to each other. And here this angle and this angle here. These two are corresponding. And angle A, this much, this part is common for both the triangles. See, common means it's there in both the triangles. In the small triangle also you have angle A, this much. And in the big triangle also you have that angle A. So that's a common angle. Okay, so you have tried all the three properties. Angle A is equal to angle A. Don't write angle A because angle A has so many angles, right? So you have to write the full name for this angle. What's the full name for this angle? Okay. Yeah. BAN. Okay. So say BAN is for the big triangle, and for the small triangle that is DAM. So we can write BAN is equal to DAM. What's the how do we know? Common angle. Okay, next. Angle D. So
Angle D is
angle
equal
D,
to
write the
angle.
full name again. ADM is equal to angle ABM. Oh, write it the other way. If you're writing the big triangle first, then do the small triangle second. Okay. Now, since I wrote the big triangle first, then here also I write the big triangle's angle first. So which is that? Angle ABN for the big triangle is equal to what for the small triangle? ADM. Property is corresponding. Similarly, third one is angle M and angle N. So for the big triangle is A and B. It's equal to angle
AMD.
AMD. Again, corresponding. Okay. So therefore, triangle, not angle, triangle, big triangle is ABN is similar to triangle ADM. So this is one set of two corresponding, two similar triangles. The question is find all the possible pairs of similar triangles. So which other triangle is similar? ADM, ADM, and ABC. If you're going to C, then E, no?
ABC and ADE.
Yes. This full big triangle, ABC and ADE, right? These two triangles are similar. So same we have to show that. And next, which other triangle is similar? ANC and AME. They're also similar. So you have three sets of similar triangles here. Okay. So like how we wrote this, you have to write that for all the sets of triangles. Okay. Now find the length of ME and DM. ME and DM. Now ME is part of which triangle?
Angle ADM.
That AME and ANC. The third one was what we proved. So you will use those set of properties to prove that. And next, DM is part of what we solved right now. Right? DM is part of the triangle ADM and ABN, part of those two triangles. So then you have to show those, use those ratios to prove to find that angle. Is that clear, everyone, how to do this?
Yes, sir.
So just write this one triangle and find these missing values now. Don't need to show all three right now because you understood what to do, right? Same like this, you have to show for all the three. So do this one and then find the length of ME and DM. Do that. Yeah, what is ME? Tell. You got or not? No. See, ME is corresponding to which side? NC. And these two sides are proportional to which any other side that we know of. AC. AC. No, ME is part of the small triangle. So which is a small triangle? AE upon AC. Okay, do we have AE and AC? Okay, AE is how much? We can just draw that separately. Okay, AE is 15 and EC is 9 and NC is 6. Okay, so we have the values. ME is what we have to find. ME upon NCEA. The NC is 6 is equal to AE is 15 upon AC. How much is AC? AC is 15 plus 9. So 24. Got it? So then now take 6 on the other side. Three fives are and 3 eights are. Here 3 2. 2 threes are, 2 fours are. So 15 upon 4, which is half of 7.5, 3.75. So you can draw like this part of the triangle that is required, only the part of the triangle that's required, draw that and find. Now do DM also same way. Okay, did you all get DM? No? Why? What's the doubt? Only one value is there? Okay, so tell me what is the formula? What is the ratios? DM upon BN is equal to A, okay, AD upon AB, which is also equal to AM upon AN. Okay, so from this, what all we have? All right. So AE is 15, EC is 9, NC is 6, BN is 24, BN is 24. See, listen here. We have 3 sets of corresponding angles. What, you got something? See, we have 3 sets of similar triangles. 3 sets of similar triangles, right? If the first triangle is similar to the second triangle, and the second triangle is similar to the third triangle, what does it mean? It means first triangle is similar to the third triangle also, right? If the first and second triangle is similar, and the second and third are similar, it means all 3 are similar, right? So, can we say that this is also equal to AE upon AC? AE and AC are part of the big triangle. Even though we're not comparing those 2 triangles, since all the 3 triangles are similar to each other, we can compare. This is the small triangle. Which triangle is this? This is triangle ADM and triangle ABN. ABN. These are the 2 triangles we are writing for, right? This is for the big triangle or the small right side triangle. We can say that also, right? Now we have these 2 values. So we can compare that with whatever is here. Okay? So we'll take the required angles, which is this one and this one. Use that and find the missing value. We do that. We will end with this. Meeting is getting over. I'll send you some homework on the group. Okay? Actually, your homework is here. Do your question paper as your homework. Anna, your question paper you can solve. Others can solve their question paper. Or I'll send it on the group. You guys, one of you know, when you go home, take a photo of the question paper and send it. Who will do that? You want? You don't have the question paper. Beryl? Why did you lose it? These are important documents. You have to keep it safely. All right. We'll end with the meeting then. Yeah.
Bye.
Bye. All right. In this question 24. So first QR is parallel to AB. We can draw them as one set of triangles here. Okay, this is QR and this is AB. Okay, so here you have two triangles, PQR and PAB. Now they both will be, since these two lines are parallel, then we can use these laws, like these two angles are what? The corresponding angles. Okay, and this angle R and angle B will be also corresponding. And angle P is common angle. Okay, so using these three properties, you have to show that these two triangles are similar. Okay, then the next you have is DR. DR is parallel to QB. So for that, we can look at this triangle like this. Not so slanted. Okay, this is DR and this is QB. You see, I'm only drawing the required triangle that I need, okay, so that it's not confusing. So now since DR and QB are parallel, again, angle D is equal to angle Q corresponding, angle R is equal to angle B corresponding, and this angle on top, which is P, will be the common angle. So again, these two triangles are also similar. Okay, for the first one, you have triangle PQR is similar to triangle PAB. And in the second one, you have triangle PDR is similar to triangle PQB. You all
Sir,
understand?
in exam, to draw the similar triangle like this separately.
It'll be easier for you. It's not necessary to draw. They won't give you extra marks, but you will understand the question better if you draw them separately like this. Understand? Take out the required diagrams, take out the required triangles you need to do a calculation on. Take them separately and draw them. It becomes easier for you. Okay.
So,
Next, PQ square. Now, where is PQ? PQ. Okay. So PQ is there in this triangle PQ. Even this triangle has a PQ. Okay. So we could use any one of this. We don't know what as of now. So PQ, then PD. Where is PD? PD is this much. Okay. So we're talking about the second set of triangles because PD is not there in the first triangle. Okay. Let me use a different color. Okay. Oh. Okay, that's PD. And then PA. Where is PA? PA is this full thing now. Okay. So they're mixing up both the triangles. Both the sets of triangles, question is coming from both. Okay, so how do we think? How do we do this? Now, let's see what they're asking to prove. They're asking to prove that PQ square is equal to PD into PA. Let's simplify this and it should become PQ into PQ is equal to PD into PA. Okay, we're just simplifying the answer so that we know what we have to solve. Okay. Now, if we take PQ on one side and say PD on the other side, or PA, we don't know what as of now. Let's take PQ, and if we take PD on the other side, we'll get PQ upon PD is equal to, on the right side, we have PA upon PQ. Okay, now let's see if this makes any sense. So look at your diagrams. PQ upon PD. So that's talking about the second set of triangles. PQ is the big side, PD is the small one. Is equal to PA upon PQ. Now look at the other one. PA is the big one upon PQ. Okay, does this make sense?
yeah, both are proportional.
PQ upon PD, that is small upon big. And here it is big upon small. Do you see that? PQ is the small This is small and this is big. Correct? Wait. No. PQ is big. Yeah. PQ is the bigger side and PD is the smaller side. And here PA is also the bigger side. PQ is the smaller side. Okay. So we have correctly separated them, big upon small. Okay. Now this is what you have to prove. You have to get this. We don't know this as of now. This is what we have to get so that we can do it reverse and we can get what they've asked us to prove. Okay. This is what we have to get. How do we write this now? Thing is, these two triangles are similar to each other. That is PDR and PQB. And here these two triangles are similar to each other. But one triangle from the right side is not similar to one triangle from this side. And the relationship is like that. So,
Yes, sir.
just let me go back and see if there's any example. Does anyone have the solutions to this, like a book or something where you can see the solutions? You can just see that and explain. It's not there in your book? Okay. Yeah, so sometimes the questions become a little hard. I think they took it off the book because it's confusing. See, yesterday we saw that two of these sets of triangles, they were related to each other. Like you could show that if triangle A is similar to triangle B, and if triangle B is similar to triangle C, that means what?
And which exercise is this?
It's not in your textbook, okay? Yeah, so we won't do this, but we were at least able to understand how the question is, okay? How we were able to separately draw them and then we can compare. Okay, yesterday what we saw was if A and B are similar and B and C are similar, that means A and C are also similar. So like that, if there are triangles that are similar out of the three, it's easy, okay? But here this was a little confusing. So let's skip this question. We'll see a question from your book. Show me your textbook.
Anna, which is this question?
It's not in your textbook, this question, okay? We'll do one question from your textbook. Okay, question 11 from your textbook we'll do. 15A, question 11. It's question 12 in my book, 11 in your book. Okay, look at this question, everyone. Given angle GHE, that is GHE, so you're 90 degrees, and DFE is also 90 degrees. DFE, okay, 90 degrees marked on your diagram. Okay, listen very carefully, everyone. Next, DH, okay, we'll do one thing. We'll draw these two triangles. There are two triangles here. We'll draw them both separately. Instead of putting them together, we'll draw them separately and then we can study them easily.
Why at 5 o'clock today?
You ready? I'll drop it. You ready? Okay, so this is one triangle EFD and the other triangle GHD. Okay, so obviously it is to prove that these two triangles are similar. Once you prove that the two triangles are similar, you can apply these values in the proportional sides, okay, in the ratios of the proportional sides. Okay, so here DH is equal to 8. Where is DH? DH is 8. DF is 12. DF is 12. DG 3x minus 1. And DE is 4x plus 2. Okay, so out of the two triangles, they have given two sets of sides. Now, which are the sides that are proportional to each other? Okay, we have to first show that these two triangles are similar, and then we have to show which sides are corresponding, which corresponding sides which are corresponding sides, and they'll be proportional to each other. Question is to find DG and DE. DG, okay, that means this DG you have to find, and DE, you have to find this value. Okay. All right, so tell me for these two triangles. So write like this: for triangle DEF and triangle DGH. These are the two triangles that you're going to prove. So show me, prove to me that they are similar. You need 3 points.
Angle F is equal to angle A.
Which one?
Angle F is equal to angle A.
H. This is H. Okay, angle F is equal to angle H because both are 90 degrees. Correct? Okay, you have one angle. Then what else? Look at angle D. They are the same angle. Look in your main diagram now. See, that angle D is common for both the triangles. Do you see that?
A is
So
equal to
angle
angle
D is
D.
equal to angle D, which is a common angle.
Angle.
That's it. You need two angles only. We don't need the third one. Okay. So we can write by angle postulate. These two triangles are similar. That is, triangle DEF is similar to triangle DGH. Is everyone clear how we prove the two triangles are similar? This is one of the theorem, AA postulate, right? All right. Now, since the two triangles are similar, the corresponding parts of the similar triangles are what?
FD upon HD.
Are proportional. You have to write the statement, no? Yesterday also we wrote the statement. Corresponding parts of those two similar triangles are proportional. So which are the corresponding sides now? Okay.
FD
I'll tell
upon
you one
HD.
side on the left side triangle. You tell me which is its corresponding side on the right side triangle. Okay. So ED. ED is corresponding to which side?
GD.
GD. How do we know that?
Because both are hypotenuse.
It's a hypotenuse, right? So ED for this triangle is corresponding to DG on the second triangle. All right. Next, FD. FD on
HD.
the first triangle is corresponding to
HD.
okay. See now, look. FD is between the 90 and this known angle. FD is between the 90 degree and this known angle. So in this also, which is the side between 90 and the known angle?
HD.
HD. You understand? HD is the side corresponding to FD. All right. And what's the third remaining side? The side that we don't have? EF. EF is
EF.
corresponding to
GH.
Is that clear, everyone? And is that clear? All the three sets of sides that are proportional to each other we have written here. Okay. Now you have to find what? You need to find DG. Okay, you have
DG.
values. What all values you have? Just next to it, put all the values that you have, take the required ratios and find the missing value. Okay. All right, continue this much and do it all of you. I'll just come in 1 minute. Okay, what was X in this first question?
7.
X is 7. Did you all get that? Ryan, Nathan,
7.
Anna?
And I got 4/3.
Just take a photo and send. No?
Yeah.
Once you get the value of X, then you found the two sides. What is the sides?
20 and 30.
This is how much? This is 30. And this is 20.
20.
27th one, anyone did? Here also?
Sir, triangle PQM is similar to PMR, no?
PQM and PMR. Yeah. And PMQ also probably. Okay.
Sir, angle M is common angle or 90 degree.
What?
Angle M is common for both the triangles, no?
Angle which one? M.
M.
M is common for the left side and the right side triangles. There are three triangles here. You have the left side triangle, you have the right side triangle, and then you have the full triangle. Okay. Now all three triangles are similar to each other. Why? I'll just call them the left side triangle, the right side triangle, and the middle triangle. Okay, just to make it easy. So look now. The left side triangle and middle triangle, they both have 90. And second thing that's common is these two angles. You see angle Q and angle Q is a common angle in both. So because we have two angles, these two triangles are similar. Is that clear, everyone?
Yes, sir.
Ryan, Nathan, Anna, put your cameras on. I'm explaining something. Good to see you. Okay. Now, if you're comparing the middle triangle and the right side triangle, how are they similar?
Where 90 degree, angle M.
Okay, the 90 degrees there, angle P and angle M. The 90 degrees are same. And what else is same? Angle P is not same for both. Here angle P is 90, here angle P is not 90. Look at the full
Angle
triangle. Which is this angle
Angle
that's
R.
common? Angle R. You see angle R and angle R over here. They're exactly the same. You see they're a common angle. So those are the two angles that are common there. Okay. So like that using AA property, A postulate, you can show that both the left and the middle are similar. Also the middle and the right are similar. Therefore, all three triangles are similar to each other. Okay. All right. So now for the left and the middle, which all sides are corresponding? Let's start with the hypotenuse. Okay. On the left, what is the hypotenuse?
QP.
QP. On the middle one, which is the hypotenuse?
QR.
QR. What is this? R. QR. Okay, next the side that we know between the angle and the 90. That is QM. So QM is corresponding to
QP.
QP because that is between the angle that we know and the 90. QP. And the third one is the unknown angle, that is PM, unknown side. PM is corresponding to which is the unknown side over here?
PR.
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 That is the third and remaining one. Okay. Now in the middle and the right triangle, tell me all the sides that are corresponding. So first we'll start with the hypotenuse. That is QR. And over here?
PR.
PR. Okay. Then the angle, the side that we know between the 90 and that known angle. PR. And here,
PR.
which is that one? MR. It's between the 90 and the known angle. And then the third remaining one is what?
Unknown QP.
QP. And here, which one is that? Huh?
PR.
PR or PM?
PM. PM.
It's between the 90. Here. PM. Okay, so once we have this, now we just have to put the values, whatever we know, and then find the missing value. So next to this, with a pencil, you take and put a question mark next to what you have to find. So here they're asking you to find PR. Okay. So PR is
So
here.
you have to show any two triangles similar, no? In solution.
This is all what we have. Let's see what we need. Okay, based on what we need, we will you only use that. So here we need PR. So PR is there in both. Here also PR is there. Here also there's PR. Because PR is part of the big triangle. Now, if you're using this, then we need to know PM. If you're using this, we need to know QR. So depending on what we have, we will use. So what all do we? Out of all these ratios that we have figured out, the only ratio that we can use over here is this part here. QR upon PR is equal to PR upon MR. Because in this, the only missing value is PR, and we have QR and we have MR. On the other sides, There is PR here, but there's no PM. So we can't use that. And plus all the other fractions also, we only have either numerator or denominator. So we can't use that. Right, so this is what you'll be using. Cross multiply and find PR. 36. So PR will be square root of 36, which is 6. Okay, is everyone clear how to do this? So did we need to do all of this? We didn't need this left side. We didn't need to prove the left side triangle and the middle triangle. But we don't know, right? Or what we should do is, first you look at all the values that are given and then see which triangle it is part of. So what is given here? QR is given. QR is part of which triangle? The full triangle. MQ, the left side triangle. And then we have MR also. So we have all these values here, QM, QR and MR. And they're asking you to find PR. So now PR. So PR is part of which triangle? It's part of PMR. It's also part of PQR. It's part of the right side triangle and the middle triangle. So that gives you a hint that you just need to prove these two are similar. This one and this one. The middle triangle and the right side. We have nothing to do with the left side triangle. Understand? So then we can save some time and not do this left side one. Okay, we just have to do the right side one. Now, how do you write this down in your writing? You will just write for triangle PQR and PMR. And then you show the two angles that are equal to each other. And then you show that, okay, these two triangles are similar. Therefore, then you will write all these ratios. Okay. Then you will write taking required sides and then write this ratio and then solve that. Okay. But before writing anything, what you have to think, which two triangles to compare? That is what your first question should be. How do we know that is? Based on what values are given and what we have to find. Okay, I've explained everything, what is needed and what is not needed also, so that you understand how to do this question. Is everyone clear on this? All right. Yeah, I think we'll stop with this. Okay, the next is another theorem, basic proportionality theorem. We will do that when there are more students, probably on Monday we'll do this. Okay. So your homework. Show me your textbook. Question 13, 15. 13 and 15. Okay, I'll send a picture on the group. And then next class, we'll do the basic proportionality theorem. That is the next part of the chapter. Okay, we'll go to the second part of this chapter, theorem 2. Okay, so this is a relation between the areas of two triangles. So let's see how this is. Suppose you have one triangle here, ABC, and you have another triangle, XYZ, and say they both are similar. You have already proved that they're similar. How are their areas related? Okay, so area of triangle ABC upon area of triangle XYZ will be equal to any of the corresponding sides if you square them. For example, AB, what is the corresponding side to AB?
X1.
So it will be AB square upon XY square. This is the relationship. Okay. The ratio of their areas will be the ratio of the squares of any of the sides. Okay. So it can also be equal to what? Tell any other set of corresponding sides.
BC.
BC square upon
YZ.
Or it will also be equal to
AC square upon X square.
That's it. Okay, is that clear? Square the sides, you will get the ratio of their areas. Any doubt in this theorem? Ryan, you just joined. We just saw the relationship between area of two similar triangles. The ratio of the two triangles' areas will be equal to the ratio of any of the sides squared. Just look at this and see if you have understood it. Write it down, the rest of you. All of you write it down. Okay, go to this exercise 15C. Question 3 in your book. Later, before that. Okay, do this 1 in my book. It's not in your book. So look at this. Okay, the ratio between the corresponding sides of two similar triangles is 2:5. So what is this 2:5? Ratio between
Two corresponding sides.
one set of corresponding sides, say AB upon XY. Okay, they have given that as 2:5. Find the ratio between the areas of the triangles. Yeah, so it's a direct application of this formula. So area of triangle 1 upon area of triangle 2 will be how much? Huh? This corresponding sides, you have to square it. That means 2 square upon 5 square. See, Aman, you square any of the corresponding sides, you will get the ratio of their areas. Okay, that is the theorem we just saw. So area of triangle 1 upon area of triangle 2 would be any set of corresponding sides, you square them. So 2 square upon 5 square. So the answer is 4 upon 25. Clear? That's it. You can't separately find area of one triangle or area of second triangle. You can just find their ratios. Unless one of the area is given. Suppose area of one triangle is given, then you can cross multiply and find the area of the second triangle. Okay. All right, write this down. Similarly, do the second question here. 1, 2. In the second one, what have they given?
Areas of two triangles.
Yeah, they gave the areas. You have to find the ratio of their sides. It's the opposite way.
Yes.
So here, what's the answer anyone got? 98 upon 128 is equal to one side square upon the other side square. So what do we do? Yeah, to find the side, we need to find the side upon side, not side square. So we need to square root the other side. Okay. So square root of 98 upon 128 is what you have to find. Now 98 is not a perfect square. 120 is not a perfect square. So how do we do this? Huh? Before that, you should see if you can cut these numbers. 98 and 128 can both be cut in two tables. If you cut in two tables, it will be 49 upon 64. Now 49 and 64 are perfect squares. So you can find the square root of this. Therefore, side upon side will be 7 upon 8. 49 square root is 7. 64 square root is 8. That's your answer. Okay, is this theorem clear for everyone? How to use it? We saw both ways. From the sides, we can find the area or ratio of areas. And from ratio of areas, we can find ratio of sides. All right, we'll go to the next theorem, which is theorem 1. Okay. Now, suppose I draw a line parallel to one of the sides. Okay, say you have a triangle ABC. And now I drew a line parallel to BC called DE. Okay. Now we have two triangles over here. What are the two triangles?
ADE and ABC.
Okay. Triangle ADE and triangle ABC. Now, first of all, are these two triangles similar? Yes. Whenever you have a line parallel to one of the sides, the triangles will automatically become similar. Automatically means using one of the theorems. How do we show? Which theorem can we use? Or which axiom? What was that called? Postulates. Which postulates of similarity that can we use to find out that they are similar? A. So angle D is equal to angle B. Angles. Similarly, angle E is equal to angle C. So we got two angles. And the third angle is the common angle here. Angle A is common for both, right? So using this, we know for sure that these two are already similar. Even though you have to show that they are similar by showing these 2 or 3 Which one? D and B are corresponding. E and C are corresponding. Okay. All right. So by AA postulate of similarity, these two triangles are similar. That is, triangle ADE is similar to triangle ABE. And because of this, we also know that their sides are, the corresponding sides are proportional. So tell me all the corresponding sides. I'll tell you one side, you tell me the other side. AD upon which is the
DB.
corresponding side to AD? Huh?
DB.
AB.
AD and AB. AD is for the small triangle, AB is for the big triangle. So this will be equal to AE upon
AC.
AC, right? AE will be corresponding to AC. And the third side is DE upon BC. Okay. This is what we have learned in the previous exercise. Yes, these three sets of sides are proportional to each other, or these three corresponding sides are proportional to each other. Now, what we're learning here, theorem 1 it's called the basic proportionality theorem, BPT. What basic proportionality theorem states is AD upon DB. Look at DB, it's not part of a triangle, it's one section of that big triangle. But this theorem states that AD upon DB will be equal to AE upon EC. Did you see that? That's it. Just these two ratios. When this ratio will be true is if DE is parallel to BC. So if DE is parallel to BC. This is basic proportionality theorem. Is that clear, everyone? I'll say that again. If DE is parallel to BC, then we can apply basic proportionality theorem. What does basic proportionality theorem state? AD upon DB will be equal to AE upon EC. Is everyone clear with basic proportionality theorem? All right, write down this theorem. See, I've written both ways. This first thing what we've written is from the previous exercise, and basic proportionality theorem is this one. Okay, write down both. Okay, look at this question in 15b, question 1. In the following figure, point D divides AB in the ratio 3:5. Okay, this is your triangle. AB is here, and point D okay, what do they say about point D? Point D divides this line AB in the ratio 3:5. That means this part is 3 and this part is 5. Correct? Okay. And secondly, we can also see in the diagram that this line DE is parallel to BC. DE is parallel to BC. Now, there's another theorem. I think it's not in 10th standard, it's in a smaller class. If the line, I think in last year, no? I'm not sure where it is, but this is the theorem. That is, if D divides the line AB in the ratio 3:5 and DE is parallel to BC, then AE to EC also will be 3:5. If AD to DB is 3:5 and DE is parallel to BC, that means actually it's the same theorem only. BPT only, it's in another way. Okay. See, it can be said in different ways. One way is what we said before. That is, if DE is parallel to BC, that means what? AD upon DB will be equal to AE upon EC. Now, in another way, how if we look at it, if AD to DB is given and DE is parallel to BC, then AD upon DE will be equal to AE upon EC. I mean, it's the same thing only, right? Okay. All right. So since these two lines are parallel, both these ratios are equal. That is what BPT states. Okay. Now they're asking you to find certain things. First one, AE upon EC. So just looking at the diagram, you can tell what is AE upon EC. AE upon EC, Leah.
3.5.
Correct? Okay. Second one, AD upon AB.
3
AP upon AB. AB is the full thing. Full thing is 8. 3 plus 5.
8.
So 3 upon 8.
3 upon 8.
Third one, AE upon AC.
3 upon 8.
3 upon 8. Okay. The ratio is 3 upon 8. We can't say that this is 3 and this is 5. Just the ratio between these two sides is 3:5. Correct, no? Ratios are not like single values for each. If I say your age and my age is in the ratio 3:5, it doesn't mean 3 years old and 5 years old. The ratio is 3:5. So that's what this is. Okay, so that is the first three. Next question. If DE is 2.4, see now these are the actual values. If DE is 2.4 centimeters, find the length of BC. So what will be the ratio between DE and BC? The ratio between DE and BC. Is it 3:5? DE to BC will be equal to which other? Tell me another ratio that this might be equal to. See, these two triangles are similar. So you have three ratios, right? So this is one ratio. Tell me another ratio. DE upon BC will be equal to, say, AD. AD upon?
BC.
Huh?
DE.
Not DB. AB. Because see, this is the full side of the triangle. DE is the full side of the small triangle. BC is the full side of that big triangle. So you have to compare it with the full side. So AD upon AB. Not the this is not BPT. This is the original theorem that we studied in the first class of the chapter. Okay. So DE upon BC will be equal to what? AD upon AB, which will also be equal to AE upon AC. Is that clear? And what is this ratio? AE or all this is 3. And what is the denominator? 8, not 5. Correct? 8 is the whole thing. All right. So we have the required sides that we need is, or required ratio we need is this DE upon BC and 3 upon 8. Okay. So what is DE? They've given DE as 2.4 centimeter. We have to find BC. So 2.4 upon BC is equal to 3 upon 8. Then we cross multiply that and find the value of DC. In the second question, they've given BC. You have to find DE the opposite way. Again, you use the same ratios and find that missing value. Is that clear, everyone? All right, do this. If any doubt is there, please ask. Okay, did you get the answer for BC?
Yes, sir. 6.4.
6.4 centimeters. And for the last question, DE?
1.8 centimeters.
Third in my book, fourth in your book. So first of all, draw the diagram. So the line PQ is drawn parallel to the side BC. Okay. Just try to keep the parallel lines parallel to the floor. Okay, horizontal. You can draw it like this also. See how this diagram here is. The parallel line is parallel to another side, AB or something. Okay. But when you draw it this way just to make it more easier to understand. So line PQ is parallel to BC, which cuts side AB at AB is cut at P, inside AC is cut at Q. The full AB is 9 centimeters. AC is 6 centimeters. AQ is 4.2. Find the length of AP. Okay. How do we do this? Do we use BPT, basic proportionality theorem, or just the normal theorem between two similar triangles? Yeah. See, because we don't have QC and PB. QC and PB is then basic proportionality theorem. We have the full triangle. If you want, you can draw both the triangles separately. Okay, that way it will be very clear to understand. So APQ is the small triangle and ABC is the big triangle. So in the big triangle, we have AB 9 centimeters and we have AC, which is 6 centimeters. In the small triangle, we have to find AP and we have AQ, which is 4.2 centimeters. So now you can clearly see, right, the triangles that are corresponding to each other. So write the theorem and solve it. What's the theorem? AP upon is equal to, which is not required, which is also equal to upon AC. Okay. So we're taking only the required ratios, this side and this side, cross multiplying and finding the missing value. All right, do it. Any doubt, please ask. Nathan and Ryan, need to see you guys. Corresponding sides. AP is corresponding to AB, means matching sides. AQ is corresponding to AC. So when triangles are, first of all, the triangles are similar. Similar means same shape. Since the triangles are similar, their corresponding sides are proportional. That means AP upon AB will be equal to AQ upon AC.
So 6.3 centimeters.
6.3. Do you all get that? Next is question 6 in my book. Question 6 in my book, question 7 in your book. Okay, this is your triangle, right? D is drawn parallel to BC, with D cuts AB and E cuts AC. If AB is equal to 5BD, AB is equal to 5BD. Oh, so this is given a different way. It's not given as a ratio. How do we convert this into a ratio? Take the BD on the left side. So we'll have AB upon BD is equal to 5. Then you put upon 1. So you have a ratio now. AB upon BD. AB upon BD. So the full AB is 5 and BD is 1. So AD will be how much then? The whole thing is 5 and DB is 1. So AD will be 4. Correct, no? 5 minus 1. All right. And what else is given? EC is 3.2 centimeters. EC's value is exactly 3.2 centimeters. Find the length of AE. All right. So here, what do we use? Do we use the ratios of proportional similarities, or should we use BPT? We'll use BPT because we have BD and EC. Okay. So according to proportionality theorem, okay, first we always have to write triangle ADE is similar to triangle ABC. Okay. Okay. Then since D is parallel to BC, then what is the theorem? The BPT theorem. AD upon DB is equal to AE upon EC. In bracket, you write BPT, basic proportionality theorem. You have all the values, substitute the values and find the missing value. Tell me the answer once you get it. What's the answer? 12.8 centimeters. Got it? Aman got? Was it out? Huh? AD upon DB. You got this ratio? You understood this? How much is it? Tell me. Huh? What? I can't hear you. You understood how we got 4 and 1? They only gave 5 and 1, but 5 is the full thing, so we got 4. So we have 4 upon 1, AD upon DB. And AE upon EC, AE is what we have to find. And EC is given 3.2. So cross multiply this. AE, if you cross multiply, you'll get 4 into 3.2. That's 12.8 centimeters. Okay, do this 10th one in my book, 11th in your book. Okay, let's read it together. The given figure shows a parallelogram ABCD. ABCD, okay, parallelogram. E is a point in AD and CE, wait, what? E is a point in AD and CE produced meets BA. CE produced means if you extend CE, it meets BA at a BA produced at point F. So if you produce CE and if you produce AB, you will meet at a point called F. That's what they mean. If AE is 4 centimeters, AE is 4 centimeters, AF is 8 centimeters, AB is 12 centimeters. Find the perimeter of the parallelogram ABCD. Perimeter of the parallelogram means you need to find all the sides. Right? AB we have to find BC. That's it. Right? Because AB will be also equal to CD since a parallelogram. And whatever BC, that will also be equal to DA. So what we have to find exactly now? To find the parallelogram, what do we have to find? We just have to find DE. Because see, we have AE. We find DE, then we have the full DA. So how do we find DE? Do you see two similar triangles? Or yeah, two similar triangles here. Which are the two triangles we are comparing?
Triangle DEC and triangle FEA.
Okay, FEA and what is the other one you said?
DEC.
DEC. Here, these two triangles. Okay, so are they parallel to each other? I mean, are they similar? Okay, how do we prove they're similar?
Angle is equal to angle E, common angle.
No, there's no common angle. See, these two angles which are marked here, what are they?
90 degrees.
No, what 90 degrees? Not 90. These are alternate interior angles. Remember, see, the lines are parallel, Alchem. AB and DC are parallel. So we can apply the transversal properties corresponding, alternate interior, all those angles. So angle A and angle D are alternate interior angles. Is that clear? Next, angle F is equal to angle C. See, alternate interior. And also you have this angle E is equal to angle E on this side, vertically opposite. So by the AAA property, these two triangles are similar. Since they're similar, you can prove all their sides are proportional to each other. All their corresponding sides are proportional to each other. Which are the corresponding sides? See, if you're getting confused, what you should do, draw both the triangles either together or separately, but don't use the rest of the part. We don't need all that. Okay. So this side, FA is corresponding to which side?
DC.
DC. So you can write FA upon DC is equal to, which is the next set of corresponding sides? AE
upon DE.
E. And the next set of corresponding side?
FE upon EC.
FE upon EC. So these are the three sets of corresponding sides. They are proportional to each other. So now we take the required sides. Which are the required sides? FA and DC. FA and DC we have. AE,
And E and D.
AE we have. DE we have to find. And nothing to do with these two. Where we don't have it, we don't have to find it. So these are your required ratios, these two. Okay. All right. So first, how do you start? First, you have to write like this. For triangle, this and this. And then show all the three angles that are equal to each other. Then you write, since the triangles are, since this triangle is similar to this triangle, therefore this. These ratios. Okay, do it. I'll just come. I'm writing it here the way you're supposed to write it, okay? This much you have to write before you start solving anything. Okay, look at how we did it. First, we showed the two triangles that we are going to compare. For triangle AEF and triangle CD. Then we showed all the three angles that are equal to each other with their reasons. Once we showed those three reasons, we write therefore by AAA postulate, this triangle is similar to this triangle. Okay, that's the first part. Next, since the two triangles are similar, therefore what? Corresponding parts of similar triangles are proportional. Corresponding parts means all the matching parts. They're all proportional to each other. That's how we can write these ratios. FA upon what ratios we wrote in the beginning. Then you will write what? Taking required ratios. Taking the required ratios, that is FA upon DC is equal to AE upon DE. That is the required ratios. Then in that we will substitute the values, find the missing value, which is DE. So that is 8 upon 12 is equal to 4 upon DE. So DE is equal to 4 into 12 divided by 8. So 1s are, 2s are, 2s are 6.
And the perimeter is 44.
Okay. It's all in centimeters. So 6 centimeters. Okay, so we got DE is 6. So total DA is 6 plus 4, which is 10. So BC is also 10. So then when you add all the sides, you get 12 plus 10 plus 12 plus 10. How much is that? 44. 44 centimeters is the answer. So this is a proper question from the A part. We didn't use BPT, but just the ratios. This corresponding ratios are proportional. That rule we used and did a little complicated question. Any doubt in this question, anyone? Okay, mostly you will get like these type of questions in the exam. Little bit of the theorem with a little bit of perimeter formula and stuff, like this, parallelograms. Okay. Okay, we'll go to the next exercise. So next exercise was about the areas which we saw in the beginning. Okay. I hope all of you are clear with how to find area, the relationship between area. Just look at this relationship over here. So if you have two triangles, ABC and DEF, what does this theorem state? The area of triangle ABC upon the area of triangle DEF will be equal to the corresponding sides that are proportional. You just square them. That is a relation. So AB square upon DE square, which is equal to BC square upon EF square, which is also equal to AC square upon DF square. Okay. Now there are also some extra theorems over here. That is, look at this. See here, there are two triangles. Okay, there's a big triangle and there are two smaller triangles. The big triangle is ABC and the two smaller triangles are ABD and DEC. Now D is cutting right in the midpoint of BC. So what do we call this line AD as? There's a word for this AD. What do we call it?
Median.
Median. Median is a line that cuts the midpoint of the opposite side. Okay. Now, since AD is the median, that means BD is equal to DC. And the area of triangle ABD will be equal to the area of triangle ADC. These two triangles. Which two triangles, Aman? And ADC. They both will have the same area. They don't look same. The triangles are not similar. They're not similar, okay? But their areas are equal. So that means if we modify this formula, this relationship, and I suppose I tell you BE is 3 parts and EC is 4 parts. It's not equally divided. E is not the midpoint, but BE is to EC is how much? 3:4. So the areas of these two triangles also will be in the ratio 3:4. Is that clear? Okay, so this is not a theorem, it's just a note, okay, that you should use it if it comes anywhere, okay? I'll say that again. If BE to EC is in the ratio 3:4, then the areas of these two triangles will also be in the ratio 3:4. Is everyone clear on this? See, they've given it as an equation here. Area of triangle ABE upon area of triangle ACE will be BE is to EC. No square and all here. That square is when? The square is if the two triangles are similar. Here are the two triangles similar? No. They just have a common base and a common vertex. What is common? The base is common and the vertex, the point on top, is common for both the triangles. Then only we can apply this small theorem. Okay. So we saw two theorems, like, okay, one is for two similar triangles, their areas is in the ratio like this, square of the sides. And this is if two triangles have the same base and the same vertex, then their base, the ratio of their bases will be equal to the ratio of their areas. Okay, let's do a sum from this. Exercise 15C. Question 6 in your book. Question 6 in my book also. Okay, here. So look at the figure. Looks interesting. A lot of triangles inside this. Okay. Remember, use only the triangles that we need to use. Okay. So you have to figure out which triangle to extract from this. So in the given figure, PQR, LM is parallel to QR. Okay. So that is simple. We can show that the two triangles are similar. Also, we can apply BPT. All right. Next. LM is parallel to what all? QR. Okay, that's it. And PM is to MR. PM is to MR is 3:4. Okay. So PM is to MR is 3:4. So what else is 3:4 here? Huh? PL to
PL and
Q
NQ.
also will be 3:4. And what about LM to QR? LM to QR, they are parallel to each other. What is their ratios? 3:4? 3:7. QR is the full side of the triangle. What is the full side over here? 7. What is the full side over here? 7. So, 3:7, small triangle to big triangle. So here also small triangle's base to the big triangle's base will be 3:7. Is this clear for everyone? Without even writing, you should see all these things. Is that clear, everyone? Yes? Okay. Now what are they asking? Calculate the value of PL upon PQ. PL upon PQ. What is it? 3:7. Next, LM upon QR. LM upon QR. 3:7. We just found it out, right? Next, areas. Okay, so now we are finding areas. So you know that square you have to do, right? Okay, start doing this, all of you. Draw the diagram, write all the steps, write everything correctly. I'll also start writing it over here. You don't have to draw the full diagram, just draw whatever is required. Okay, I'm only drawing this much because that's all we need for the first and second question. See how I've written it? PL upon PQ. What is PQ? 7. How do we get 7? Is PL plus LQ. So just write it. PL plus LQ. That's how 3 plus 4 is 7. Okay, did you finish the first question? Now, second one, they're asking area of LMN. LMN upon area of MNR. MNR is here. Okay, so how do we do this? So what all we know here?
LM. MR.
See, these two triangles which I've highlighted in similar colors, they're similar to each other. Correct. All right. So LMN is similar to QNR and LQN is similar to MNR. I've not proved it, but we can prove it. Okay, let's see how to prove the first yellow triangles. LMN and QNR. How do we prove that they are similar? Angle L, this angle will be equal to angle R, alternate interior angles. And this angle here, M, will be equal to angle Q. And angle N on the top and angle N down will be equal, again vertically opposite. Okay, so that is similar, that's clear. What about these blue triangles? Are they similar? Okay, what else? These two triangles, are they similar? How do we show? Okay, vertically opposite. Anything else? Angle Q and angle M, are they equal? Alternate?
No.
No, these two sides are not parallel. LQ is not parallel to MR. So those two angles are not equal, okay? All right, so these two triangles are not similar because those sides are not parallel. See, it's like this. Okay, so these two triangles are not similar to each other, okay? All right, we just have this one thing. Okay, now which of the two triangles they're asking here to compare? Area of LMN and MNR. LMN is here and MNR is here. Are these two triangles similar? No. Is there any theorem or small theorem that we have learned about this? What? Erase out everything that you don't want. Keep only what you need. These are the two triangles we are comparing. Any relationship between these two triangles, LMN and MNR? No? Yes? What? The? I can't hear you. See, they have the same base. L, M, L, N and R. L and R. This is the common base and common vertex. Okay? So the area of these two triangles will be equal to what?
Will be equal to the full triangle that MLR.
No, their bases, ratios of their bases. It will be ln upon nr. See, this triangle is to this triangle will be. Okay, so area of this yellow triangle to this blue triangle will be their bases, ratio of their bases. That is ln is to nr. Okay, that's what we have to find. They're asking to find the ratios. So for that, we need to know ln and nr. Do we know these two values? So we need to know ln and nr. We don't know both these values. Okay, how do we find ln and nr? We know that we need those two values, not the exact values, the ratios. But to get any ratios, we need some similar triangles. So is ln and nr part of any two similar triangles?
Yes.
Which similar triangles? You see these two
From
L, N, R. This is M, Q. See, these two triangles are similar. We already showed that just now. And we need to find ln is to nr. This is what we have to find. Now, do you see that these two sides, ln and nr, are corresponding sides? For these two similar triangles, ln and nr are corresponding sides. So we just need to find ratios between the top triangle and the bottom triangle. Any sides. Even if we find lm upon qr, that will be equal to ln upon nr. Okay, wait, we'll go slowly. Let's first show that these two triangles are similar. LMN and NQR. Okay, so how do we show that these two triangles are similar? I'm writing in short. Angle L is equal to angle R. Angle M is equal to angle Q. And angle N on the top is equal to angle N on the bottom. Okay, so by AAA, we can show that these two triangles are similar. You understand that? All right. So now since the two triangles are similar, corresponding parts of similar triangles are proportional. We write that statement and then we show all the sides that are proportional. LM is proportional to, sorry, corresponding to, LM is corresponding to QR. And then LN is corresponding to NR. And MN is corresponding to NQ. Now we take only the required sides, that is these two. We have LM. Do we have LM? How much was LM? 3. And QR? 7. That is ln upon nr. That's what we needed to find. See, we can put this value over here now. Ln upon nr. And then we have the area of these two. 3 upon 7. That's your answer. Do you understand? So there are so many triangles mixed up and we have to figure out what we want from where we want and put it together. Yeah. All right. So write down this much. Okay. Now LQM and LQN. Where is that now? LQM and LQN. So what do we know about these two triangles? LQM and LQN. Again, they have the same base and the common vertex. Okay. So they'll be equal to what? You tell me the ratio now. NM? Almost. LQM is the full triangle. So that one's base is what? QM. And LQN, that one's base is what? QN. Correct? You said MN. You said the other side. Okay? And you got the idea. So that's it, no? Since they have the common base and the same vertex, then their bases are also proportional to each other. So now that's it. We just have to find what is QM and what is QN. So QM is, from the previous question, what did we get? LN is 3 and NR is 7. Same way, even LM is 3 and QR is 7. That's how we got it in the first place. In the same way, MN will be 3 and QN will be 7. Right? We're not saying that this is 7, this is 7, this is 7. That's not what we're saying. The ratios are 3:7. This is 3:7. Here LM is to Q and that is 3:7. And this also 3:7. Like that. Separately, each of them are 3:7. Correct? So now we are finding a relation between QM and QN. So QM is what? QM is 10. This full thing, 7 plus 3. And QN, 7. That's your answer. But you can't just directly write this. You have to show which triangles you're, like how we got this. I mean, you just have to write this one more thing. For QM, you write QM is QN plus NM. And for QN, that is QN itself. Now, how did we get these values? See, like we already wrote this here. This is what we need. What are we comparing over here? We are comparing MN and QN. See, this we had not used before. We only used these two before. So now we are making use of that also. You understand? Since we have already done this, we don't need to write it again. Okay. So we can just say what? Taking required sides from the previous. Taking required ratios from the second part, from 2. Okay, we'll write that. Mn upon Nq is equal to Mn upon Nq is equal to any one of them. We have Lm upon Qr, no? So we'll write Lm upon Qr. So you write that Mn upon Nq is equal to 3 upon 7. That's it. And then you can put these values in that. Okay, I'll just explain this. Here, take. Okay, go to exercise 15A, question 15. Question 15. In my book, it's 19. Okay, so look at this 19th question here. In triangle ABC, angle B is 90 degree. Okay, I'll draw it the way you want to draw it. Okay, so ABC, A is here, B is here, C is here. Okay, and angle B is 90 degree. Okay, and BD is perpendicular to AC. BD, there's no D, but we know that BD is perpendicular to AC. So BD will be like this, perpendicular like this. Clear? Now we're comparing different sides. See, how many triangles do we have over here?
3.
3 triangles. Are all these 3 triangles similar to each other?
Oh.
So first we have to check that. Okay. So the first set of triangle, I'll say, we have done a similar question to this, I think, no? I call this the middle triangle, the left triangle, and the right triangle. The middle triangle is the full triangle. The left triangle is this ADB, and the right triangle is BCD. Okay. How do
Left
we show the
triangle,
what?
left triangle and middle triangle are similar.
Left and right are same? Why?
No, left and middle.
Left and right we can't prove. What we can prove is left and middle. We can prove that left and middle are similar. How do we do that? 190 degrees here, 90 degrees here. Both the triangles have 90 and both have this common angle A. So by AA, we can prove that left and middle are similar. Similarly, we can prove right and middle. The right triangle has this 90 here. The middle also has a 90. And this angle C is common for both. So again, two angles we have. By AA, we can show that middle is similar to right. Now, since, all three will be similar to each other now, right? Because left is similar to middle and middle is similar to right. Therefore, all three are similar to each other. So that is the first thing you have to do, show that the three are similar. And then we can apply these values. Okay. Now let's see the third one. AC is equal to 9. Think about it. AC is 9. AC is a full thing. That's 9 centimeters. AB is 7. AB is 7. Find AD. Okay, so which are the two triangles we are comparing over here? Left and
Middle.
middle. Okay, left and middle. So now tell me all the three. Dash is equal to dash is equal to dash. For the left and middle triangle, tell me all the three sides that are proportional to each other. I'll tell one side for the left, you tell me for the middle. Okay, AB. AB on the left is corresponding to which side on the big triangle, middle triangle? It's very confusing. So what do we have to do? Draw the two triangles separately. That's what we did last time. Remember, if you don't draw them separately, you can't understand which side is similar to which side, okay? You draw them separately. So the left triangle is here and the middle triangle here. Okay. So the left triangle you have BAD and this is BAC. So draw the angles. This is 90, this is 90. And which is the known angle, the similar angle, the common angle? A and A. These are the common angles. Okay. So now looking at this, you can tell which sides are proportional to which side. So AB is between the similar angle and the unknown angle. Here, which is that side? AC, between that similar angle and the unknown angle. Do you understand? Next, let's do the side between the known angle and the 90, AD. So AD is corresponding to which side over here? AB. It's between the same 90 degree and the known angle. And then the last one is the remaining. Which is the remaining? BD, between the 90 and the unknown. Here between the 90 and the unknown is BC. You understand? So now easily we can get these sides. Don't try to figure it out like this. You'll get confused. Draw them separately. Okay, now here what all do we have? With a pencil, you can write over here. AB is 7. AC is 9. AD is what we have to find. AB 7. So that's what we need. Cross multiply this. AD is a missing value. You will find AD. Is everyone clear how to do this? How do you start doing the sum? You have to show that the triangles are similar. Show all these three. Show that they're similar. And then take the required ratios that you need and apply the values and find it. Okay, just write this one down. Look at this question. I'll just explain this one and then I will be ending after this. As your homework, you will try to solve as many questions as you can from A, B, and C. Okay. D, I'll explain to you in the next class. Now here, look at this triangle, everyone. Look at this question. In the given figure, angle B is equal to angle E. Angle ACD, look at ACD. ACD. ACD, is it part of a triangle? ACD is not part of a triangle. Part of the triangle is ACB. Okay, but they have not given that. They said ACD is equal to what? BC. Where is BC? BCE. Is BCE part of any triangle? This angle marked here, that's BC. Is that part of any triangle? No. The triangle is DCE. You see that? But they didn't give that. But they said that this angle and this angle are equal. So what we just need to do is we have to add this angle. What is this? DCB. Add DCB to both the sides, both the angles. I'll just write that and show you what it will become. See what we have? We have angle ACD is equal to angle BCE. And the problem with these two angles are what? They are not part of any of the triangle. So what we'll do? See this middle part here? What is this? DCB. Add angle DCB to both the angles. Okay, so here angle ACD plus angle DCB. Here also you do the same thing. Add DCB. Angle BCE plus angle DCB. Okay. Now look at these two angles. When you add ACD and DCB, what do you get? ACD and DCB. If you add these two angles, what do you get? ACB. And here if you add these two, that is BC, this one and this one. If you add these two, what do you get? DCE. So there you have it. These are the two angles of both the triangles. They're equal. That is this full angle. Let me mark it here. This full angle is equal to this angle. Okay, so we have two angles of the triangle. So that is one set of angles that are equal. And the other set of angles is angle B and angle E. This is given that they're equal. So since we have two angles that are equal from both the triangles, that means what? These two triangles are similar by A. By A property, these two triangles are similar. And then we can use all the ratios and everything. Is that clear? All right, so just write this as the hint for this 10th question in your book. 12 in my book, 12th in your book. Your homework is to do, you have whole day today, tomorrow morning. Next tuition is tomorrow in the evening. So you have more than 24 hours. Okay, so in that much time, you will solve at least 5 to 6, 7, 10 questions, as many as you can from A, B, and C of this chapter. Tomorrow we'll do C. I mean, D. It will be centimeter. Okay. So a scale. What's a scale? It is a comparison between two things. Okay. So suppose the scale on a map is written as 1 is to 10, 1 is to 1000. It means 1 unit on the map is equal to 1000 units on the ground. Whatever the unit is. Say it's centimeter. So 1 centimeter on the map, how much is that? Around this much? 1 centimeter on the map will be 1000 centimeters on the ground. Okay, 1000 centimeters means 10 meters. So 10 meters on the ground. Okay. So this is what a scale is. Now this scale is called something, it's called the K factor. In this part of the chapter, K factor is the scale. How do you write the scale? Is as a fraction, like 1 upon 1000. So writing it like this is called the K factor. Let's look at this question here and see how we can use this K factor to find or to compare the actual size of something to the size on the map or a model. Okay, for example, if I give you a small model of a car and if I give you the K factor, you can convert it to the actual size. You can find out the actual size of the car. Or the other way, if I give you an actual car and I tell you I want it in this much scale, okay, that K factor is the scale. So then you can convert that actual car into a model, into a smaller model. So let's look at this 15th question here. A model of a ship is made to a scale 1:200. That means one part on the toy or the model will be 200 parts on the actual ship. Okay. If the length of the model is 4 meters, calculate the length of the ship. Okay, you can do cross multiplication simply and do it also. But anyway, let's see how it's done here using this K factor. So what's the K factor over here? If the scale is 1:200, then the K factor is 1/200. Okay. Now the length of the model will be K times the length of the ship. That's a formula. The model's size, model or the map, whatever, the smaller one will be K into the actual size. This is the formula. So on the map, the formula would be K into the actual length on the ground. Understand? So we can use this formula to find this now. So what we have over here, we have the K factor, which is 1/200. They're asking you, okay, if the length of the model is 4 meters. So this is the model. The model is 4 meters. We have to find the actual length of the ship, actual length L. So like that, we can apply the formula. So take the 200 on top over here. So 4 into 200 is equal to L. Therefore, L is equal to how much? 800 meters. Okay. So that model is 4 meters. 4 meters is like, 4 meters, like from here till the door is around 4 meters. That's the model ship. And that actual ship is 800 meters. It's like from here till the graveyard. It's a very long ship. Okay. Yeah. But that is how K factor can be used. So this is the formula. Is everyone clear? So if you know the model size, you can find the actual size. Or if you know the actual size, you can find the model size if you know the K factor. Very simple, nothing complex in this. Okay, that's all. That's the one formula that you have over here. Okay, write this down. Write this much down. Okay, next. Now look here. The model and the actual size, whatever we're taking, is the length of the model and the length of the actual size. Or instead of length, the height or the breadth. But we're taking a one-dimensional value. Is that clear? So what we can find using this formula is either the length or the breadth or the height. Okay, so we'll put a bracket over here and write length or breadth or height. Okay, now the same formula can be modified also to find area. So for example, area of model or area of the map or area of something, to find what we can do, K into the actual area. But here, since it's area, you have to put K square. So if you're comparing areas of a model to the actual area on the ground, then the formula is what? Area of the model is K square into the actual area. It can be any area. It can be surface area or the ground flat area. But area, if the word area is there, you have to put K square. Similarly, volume is also there. If you want to find volume of the model or volume of the map, then what will the formula be? K cube into the actual volume. These are three formulas now. 1, 2, 3. Is that clear? So remember, if it's a one-dimensional thing that you're finding, then K. If it's two-dimensional like area, K square. If it's three-dimensional like volume, K cube. Write this down. Okay, let's look at this question number 4, exercise 15D, question 4 in my book. A model of an aeroplane is made to a scale of 1:400. Calculate first the length in centimeter of the model if the length of the aeroplane is 40. So which formula are we using now here? The first, second, or third? The first one, because they're asking you to find the length. Now what's given? Actual length is given. Okay, we have the actual length. We have to find the length of the model. Clear, everyone? I'll just explain the question and then you do it. Second question, find the length in meters of the aeroplane if the length of the model is 16. So now they've given the length of the model. You have to find the actual length. Is that clear, everyone? Same formula. You're using the first formula. In the first question, they gave the actual length of the... See, what is the K factor, everyone? How much is the K factor? 1 upon 400. That's the K factor. Okay, so we have K. Now, in the first question, they have given the length of the aeroplane. Actual length of aeroplane is how much, Anna? 40 meters, right? And we have to find the length of the model. Okay, clear? Do that first. Write the formula, like modify the formula based on the question. Length of model is equal to K into length of aeroplane. That's your formula. What's the answer?
16,000.
Huh? 0.1 centimeter or meter? See, this is in meter. So your answer also will be in meter. So when you cut this, you're getting 0.1 meter. Length of the aeroplane is meter, right? So your answer will be in meter. So 0.1 meter means how many? Is there a better unit to write this? 10 centimeters. So you write your answer like that. Okay. All right. Now do the second part, same formula. This time the length of the model is given. You have to find the length of the aeroplane. What's the answer? 64 meters. So you're getting 6,400 centimeters, which is 64 meters. Okay, do the next one also. Question number 5. Now here you have length, breadth, and height. Okay, and what are we finding? Actual length, breadth, and height. Are we finding volume? No. You're finding the actual dimensions, means you're finding the actual length, actual breadth, actual height. They're not saying find the volume. See, you might think, okay, 3 values are given, length, breadth, and height. But you see what they're saying. The dimensions of the model are 1.2, 75, and 2 meters. So they've given the length, breadth, and height separately. And they're asking to find the actual dimensions of the building. Means what they're asking? Are they asking the volume of the building? Or they're asking the length, breadth, and height? They're asking length, breadth, and height. So you're converting 1.2 meters into the actual length. Same way, the breadth you're converting to the actual breadth. So 3 times you're using the formula. So which formula? K or K cube? K only, the first formula. Because we're finding length separately, breadth separately, height separately. We're not finding volume here, okay? Okay, did you get the length, breadth, and height? What is the actual length? 36 meters. You all get that? What is the actual breadth? Okay, 22.5 meters. Let me write down the values here. Beryl, you got it? So length is 36 meter. Breadth is 22.5 meters and the height 60 meters. Okay, these are the values you need to get. Tell me if you got this or not. Okay, did you all get it? Come on, tell me yes. Nathan, Ahmed, Hannah, Ryan, you got this?
Yes, sir.
Okay, now look at the last question here, seventh question.
Yes, sir.
Model of a ship is made to scale 1:300. First question, the length of the model ship is 2 meter. Calculate the length of the ship. So length. Second question, area of the deck of the ship is this many meters squared. Calculate the area of the deck of the model. Third one, volume of the model is this much. Calculate the volume of the ship. So here all three are given, okay? Length, area, and volume. So you have to find that. Now, yeah, just do this quickly. I'll also do it as you're doing it. Okay. What is the volume of the ship? What, meter cube? How much did you all get? Did you get that? How much? 1, 5? 5 zeros. Is this what you all got?
Yes, Allah.
Anna, you got this?
Yes, sir. Yes, sir.
The formula is how, after substituting, you'll get 6.5 is equal to 1 upon 300 cube is equal to the, sorry, into the volume of the ship. So that is 6.5 into 300 into 300 into 300. Correct. If you take the 300 cube on the left side, it will go and multiply with the 6.5. You multiply this, you should get this answer.
Anna, in that area of deck of the model, the cutting part I didn't understand. We cut 4 zeros and 4 zeros on top, and then 3 ones are 3, 3 6 are 18, and 0 with it, and then we
3 with
cut
that 6.
3 twos are 6, and
Yeah, that last remaining 3 when the 6. So
but
3 twos are
we
6.
can. But then 4 zeros we cut there, but there are 5 zeros. What is it? 4? Oh,
There are 5 zeros. 18. No, wait. There's a
oh
question.
no, there are 4 zeros.
4 only, no? Yeah.
Yeah, I will put another extra one.
Okay, is it clear? So this chapter is over. This is the easiest part, right? The scale part is easy. The rest of the chapter, similarity, yeah, sometimes it can be confusing.